There are several game types where you may have hundreds or thousands of objects in your scene that will need to be kept updated with players, such as blocks in a voxel game like Minecraft or Trove, or even an RTS game where there are resources scattered around the map. Networking all of these objects is not ideal as you would take a massive performance hit by doing so. In this example, I have roughly 4,000 trees planted in my scene. These trees are all networked objects. I disabled the renderers on them so that they won't impact my frame rate. You can see that my frames per second is sitting around 380 FPS. I restarted play mode, this time using trees which are not networked objects. Let's see the frame rate once I remove the rendering overhead. With the renderers disabled, you can see that my frame rate is sitting around 1700. That's nearly a 500% increase in frame rate by using offline trees. And when I run this test with only 500 objects, I still see a 50% increase in frames when not using networked trees. In the lower right, I have my server and a client already connected just above that. You'll see as I add new trees to my server, and modify existing ones, that the connected client will also see their scene update. In addition, if I connect a new client, they will also see the same changes. This first bit may be a little confusing at first, so I'll be thorough. I'm going to begin with opening my world object class. World object is a container for anything you want to synchronize in your scene that is not a networked object. In my example, I showed trees. So I have a tree script which inherits from world object. I also make sure that for the object typed on my trees, whether it be in the scene or on a prefab which I intend to instantiate, that I have tree set for that object type, given that this is a tree world object. You would add all of your object types as world object types enum. In mine, I only have tree because it is the only world object I'm using, but you can have as many as you like, and make sure you give them unique numbers. For example, I have 0, 1, and the next one would of course be 2. There's not too many methods in the world object class itself, and as you can see, all of them are virtual, and I override these in my tree script. It's very important that when you inherit from world object that you always override awake and call base.awake. Update data is called on clients when receiving a data update from the server, and server can set this value as well, generally when creating a new world object at runtime. Object not default returns true if the object has changed from its default properties. You would customize this to each of your object types. When an object is not default, updates are sent to clients. Notice if instantiated is true, then object not default returns true. This is so when a new client joins, the server will recognize that this object was created at runtime, so the new client must be aware of its creation. The server will take this knowledge and send instantiated objects as well as changed objects to late joining clients. Return data simply returns the data for this world object. Data will likely be unique to your object type. Here I am using a tree object data as my data type. When I go to tree object data, you can see that it inherits from world object data. Any object data you make must inherit from world object data as this contains the basics to function. It's very important that your data type is marked as serialized field, and generally you can hide it in the inspector. This is important because data contains a property which must be serialized into the scene, and that property is known as key. I'll talk about that later on. Further down, unique to this class, I have on mouse down logic which only runs on the server. That logic will check the tree state in my data and manipulate it depending on its current state. Tree state is an enum unique to the tree object data type. One very important part to this is near the bottom of on mouse down. I perform calls to the world object manager depending on the changes. If the tree is considered removed, then I call remove world object on the world object manager. If not removed, then I tell the world object manager that the tree has updated. You would do the same with your world objects whenever they change on the server. World object data is crucial to keeping things synchronized over the network, so let's go check that out now. Keep in mind you need to write your own variation for each object type as I did with tree object data, which inherits from this class. The key is a unique identifier for every world object and is kept in sync between server and client. Keys are used to determine which objects to modify. The server will modify an object and tell clients the key of which object was modified, as well as passing in the data which will contain those changes. The reason this is serialized is because the key is assigned in the scene whenever you rebuild your scene objects. For example, if you place a bunch of objects in your scene, you'll rebuild those scene objects, which I'll talk about later. They are automatically generated a key, and that is passed over the network. Object type is used so that the serializer knows how to read and write data. Instantiated is set true when this object is instantiated. As said before, this is important for updating late joiners. Below the world object data class, I have all of its serializers. I write all of the values which exist in the world object class, and then write additional values based on my object type. This is where that custom data types knowledge comes in handy. If you haven't seen my video on that yet, you may want to check it out. Notice that if this is a tree object data type, then it will write the byte tree state, which is a necessary property to keep the tree synchronized over the network and is unique to my tree object data type, also my tree. The rest from here will be a lot easier to grasp. Most of what I'm going to show you won't require any significant modifications, if any at all. I'm going to breeze over the majority of it, but if you are interested in digging through my code, there's a load of comments available, and you're more than welcome to ask me about this video on my server. Next up is the World Object Manager, and this is a networked object which exists in my scene, and it is server owned. The World Object Manager is responsible for updating connected and late joining clients with changes made to world objects. World Object Prefab is a class for which prefab to spawn for which world object types. If I were to go back to my scene and select my World Object Manager, you can see I have an object type tree and a prefab which should spawn for that world object type, which is my tree prefab. And I just want to note that the tree prefab is indeed an offline object. I'm going to skip over dirty update reasons, and next is the added world object data. When an object is instantiated at runtime, an added world object data class is created and passed on to clients so they know what to spawn. This class will contain spawn details as well as the data for the spawned world object. Next is the rebuild scene world objects boolean. This plays an important part. Whenever you set the boolean true in editor, World Object Manager will find all of the world objects in your scene and assign them unique keys. These keys will be the same for all clients and server. Just remember to tick that checkbox before hitting play or building when you modify your scene world objects. You can probably automate the process as well with an editor script. Just below is the prefabs for the world objects. We just talked about that. The World Objects Dictionary contains all current world objects. This collection will hold every world object placed while editing, as well as those instantiated at runtime. The dirty hash set contains world objects which have been modified or instantiated. When a new client joins, these are sent immediately to that client. Let's go take a look at some of the methods you'll be using. Instantiate world object is used to instantiate a world object on the server. After a world object is returned, you may manipulate it to your liking, such as updating custom properties or data on it, and then call initialize world object, passing in the instantiated world object and its type. After initialize world object is called, the newly instantiated copy is synchronized to clients. Next up is remove world object. Remove world object is used to remove or hide world objects. If you call remove world object on an instantiated object, then it will be destroyed. If you were to call remove world object on an editor placed object, then it will be hidden. Results of this method are synchronized to clients. As you may have figured, the next is update world object. Anytime you change data on a world object, you should call update world object, as I demonstrated earlier in the tree class. And of course, like the other World Object Manager methods, whenever you update a world object and call this method, it is also synchronized to clients. Very last, I have an example of spawning world objects at runtime, and that is done in my tree planter script. If I'm acting as a server, I'll call check plant tree object, where the method will try to plant a new tree world object at my mouse position. I will get the world object that is returned after calling world object.instance.instantiate world object, passing in the type tree because that is the type I want to spawn, where I want to spawn it, and with what rotation. Then I grab its data, casting to the expected type of tree object data. I will assign any custom values, in this case the tree state, and then on the world object which was returned earlier, I'll update data passing in that modified object data. With the newly instantiated tree set up to my liking, I'll tell the World Object Manager to initialize it, which as discussed will wrap up the procedure and inform clients of the new tree. With this code, you can have as many world object types as you like, customize them, and even run special actions when they update, as I do with my tree, where it will apply visual changes after receiving an update.